Okay, average rate of change is going to be used with reference to any curved graph. So, in relation to quadratic functions, alright, so rate of change is slope, right? Rate of change equals slope. So on your end of course test, when you see the phrase rate of change, it's talking about slope. So make sure you understand that. Don't get those confused. Now, if I look at this quadratic function, does it have the same slope everywhere?
No.
No. This quadratic function has a slope that's changing wherever you are on the graph. Between any two given points, your slopes are going to be different. So if I were to look at a couple different points on this graph, let's say I look at these 2 points. And these 2 points have a given x value. Alright? I'm going to say that this is, excuse me, x1. I'm going to call this x2. Alright? Those x values are different, right? Okay? If I find the slope between those 2 x values, it's going to be a negative slope, right? If I find the slope, if I draw a line that connects those 2 points, if you will, or through those 2 points, that line is facing down to the right, which means it's negative slope. All right? Let's say I choose a couple other points. Let's say I choose a point over here. I should have labeled these things from left to right, but that's okay. I'm going to call this point x3, because this is just the third point. All right, and I'm going to take the slope between these 2 points, between x1 and x3. Now what type of slope do I have? Positive slope. So you can see that depending on where you are on the graph, the slopes are going to be different. So what average rate of change is you're going to use the word average or variable rate of change when you're dealing with a curve that changes. All right? Whereas if I were to say constant rate of change, a constant rate of change is the same all the time. So it's the same concept in terms of we're talking about slope. But we use the term average rate of change when we're talking about anything that's not a straight line. Any kind of graph that's not a straight line. Now, the way we're going to actually calculate what we call average rate of change is we're always going to pick 2 points on that graph to find the slope in between. So they'll tell you something like this. They'll say, find the average rate of change between x equals 1 and x equals 3. They'll always ask you to find the average rate of change between x values. Now, I didn't list any specific x values up here in this example, in this illustration. All right? So we're going to go to the next slide, and I'm going to put some specific x values on our quadratic function, and we're going to find the rate of change between those particular x values. The x value, x equals 1 and x equals 3. Alright, so what we have is an interval from x equals 1 to 3. Do y'all remember our interval notation? What do the brackets mean?
Okay.
Well, I'm talking about x values. That's why I put the x colon. You know these are x values because I put it x here. There were two types of symbols that we use for interval notation. We use parentheses or brackets. Brackets meant closed and that we were including the numbers. What does parentheses mean? Open, and we are not including the numbers. So if it's closed, we are including the 1 and the 3. All right, so now I need the graph. It's going to be a quadratic function. Yep. Okay. Alright, so I've got some identified points up here. I've got 3 points identified, but there are only 2 of them that really matter. Which 2 matter? Well, the point that has x coordinate of 1 and the point that has x coordinate of 3. How do we know which point to go to? Use the x values that they give you. So we always measure rate of change based on a given interval of x values. So they gave us 1 and 3 for our interval. So I need to go to where 1 is and where 3 is on my graph, and it might help you to draw a little dotted line from that x value up to the graph. Alright? Now, what are the 2 y values of these points? 1 and 5. 1, 2, 3, 4, 5. Okay? Now, how do we find slope? What's the formula?
X plus.
There you go. It's y2 minus y1 over x2 minus x1, right? Is this old? Is this old? Yes, this is old stuff right here, right? Slope. Alright, so we now know the coordinates, complete coordinates. So all we do is plug into this formula. So what is our y2 value? What do you want to call it? Usually let your bigger one be the y2, right? It makes sense because therefore you won't have a negative. What's 5 minus 1?
4. 8.
Alright, and then what's 3 minus 1? 4 over 2 equals 2. Is that hard? Now, there may be even a quicker way to do it. It won't always work out nicely this way, but what you can do is simply take the 2 points that you need and count. 1, 2, 3, 4. 1, 2. You see what I just did? I went up 4, and to the right 2. 4 over 2. Rise over run. 4 over 2 is 2. Alright, so we just determined the average rate of change on the interval from 1 to 3 for this quadratic function. Alright, so what we have here is an x interval from -3, listen, from -3 to 2. So I've laid out the graph. Alright, you'll be given the graph. That's not an issue. You're not going to have to draw the graph. Only in your notes you have to draw the graph. So what you're going to do, it will help you if you go to the x values that you're given and draw a little dotted line down to or up to wherever the graph is. So I need to go to -3. and just draw a little dotted line until you hit the graph. When you hit the graph, go ahead and write whatever that y value is. Negative 3. Okay? Alright, then we need to go out to 2. Listen. We need to go out to 2. And then again, go to the graph. Okay, what is the value of that point? The y value is negative 5. Okay, so we have our x values and we have our y values. Very simple. Now, using the equation, the formula for slope, we're going to take y2 minus y1, so that's going to be negative 5 minus parentheses negative 3 over x2, which is 2, minus negative 3 in parentheses.
That's negative 2 over 5.
Okay, so those become positive. Negative 2 over 5. That is the answer, negative 2/5.
Oh, no.
Okay? Now, could you also have counted? Yes. These are the 2 points. You can draw a line between those 2 points and just count. So we go down 1, 2, and to the right 1, 2, 3, 4, 5. Again, negative 2 over 5. Is this hard? No, this is simple stuff.
Hi everyone, welcome back. In this video we're going to talk about how to find the average rate of change over an interval. The average rate of change over a continuous interval, closed bracket, x1 to x2, closed bracket, is defined by the formula below. This formula should look pretty familiar, especially if we think about the change in y divided by the change in x. I feel like I've seen that before. You know, knowing that f of x goes along with y, maybe I could call this y2, and I could call this one y1, and I feel like, oh yeah, it looks just like the slope of a line. In a few minutes, we'll see how that connects to this concept. We're going to find the average rate of change of the function f of x equals x cubed plus 5 over the interval from negative 1 to 2. First, we need to start by finding f of 2 and f of negative 1, which, as you recall, we do by substituting the input for the x and then evaluating the function. So 2 cubed plus 5 gives us 13, and negative 1 cubed plus 5 equals 4. Now, all we have to do is find the change in y and the change in x. So 13 minus 4 is positive 9, or we go up 9 units from 4 to 13. 2 minus negative 1 is positive 3, or in other words, we go 3 units up from negative 1 to positive 2. Therefore, the change in y9 divided by the change in x3 gives us the average rate of change, which is 3. So, remember before we talked about, oh yeah, this looks just like the slope of a line. So let's take a look at what this looks like on a graph. We can actually draw a line between the 2 points that we're looking at, which are negative 1, 4 and 2, 13. And if you remember anything from your circles unit in geometry, you remember that the term for this is that this line is secant to the curve. And so if we count, using the terms rise and run that you're probably familiar with, if we count that on this secant line, we can see that I go up 9 units and to the right 3 units. And if we rewrite this as a rate, the change in y9 divided by the change in x3 gives us our average rate of change of 3. So, finding an average rate of change is just like finding a slope. We just draw a line between the 2 points on the curve that we're interested in, and then find the slope of that line. If you want to know exactly what the rate of change is, then you need to go next door and take calculus in 2 years.